Sweet. All right. Cool. So, as our host so graciously said, my name is Seth. I am an infrastructure software engineer at AcuityMD, the aforementioned medtech startup. I have been working on Kubernetes stuff for about 6 or 7 years. I kind of fell ass backwards into it. It was a bit of an accident for me. I moved from like regular IT to like a DevOpsy gig, and that job was all Kubernetes all the time. So I skipped over a lot of like Linux administration and a lot of prerequisites that I should have had, and have spent the last like 6 or 7 years learning all the things I missed. So tonight, I have a whole bunch of slides that I'm going to burn through just because this is like a dense topic. And if anybody's interested in them, I can send a link out afterwards. And then I don't have a concrete demo planned. I have a couple clusters running on my computer and a GKE cluster that I was going to poke around in, kind of just leave it open for Q&A. It sounds like this, I mean, this is my intro to Kubernetes, but it sounds like that most people are generally new to it. So whatever works better, demos or questions, that's honestly how I think people get the most out of this versus me just talking at you for an hour. As someone who has sat through my intro to Kubernetes stuff before, Wesley can attest, it can get pretty dense. I can talk for a while about this stuff. Cool. So let me get Zoom working here. All right. And Zoom share. I don't know how this will work on if this will come through full screen. So let me know if you see a tweet. Can you see a tweet?
Yep.
From our friend Alice. So this is one of my favorite Kubernetes tweets ever. This one, as you can see, is really old, but it's still funny. If any 8 Mile Eminem fans out there, sing it to the tune of Lose Yourself, and it'll hit you even harder. Cool. So this is my whirlwind intro to Kubernetes, also known as the I could talk about this all day, but I only have an hour talk. I'll stop talking about myself. My name's Seth. I worked with Wesley at Crunchyroll in the past. I'm also ex-Workday and Sysdig. I've been on the open source Kubernetes team for a little while. I think releases 1.18, 1.19, and I've lost track. I'm not as active anymore just because there's a lot of people, but this is, I guess, my other plug. If you want to get involved in the open source Kubernetes community, I'd love to chat about that. And then there is my fluffy cat, who hangs out with me most days. He's probably a better dev than I am. So cool. So we might get jump scared by some animations in this slideshow. This is one that I just recently updated, but there was a bunch of animations in it that I forgot about. I think I took them all out, so we'll find out. And the audio from folks not right next to the computer is a little rough. So if you have questions, if somebody's closer to the setup, like Wesley, if you want to repeat them, but also like feel free to stop me at any time, because my fear is I get to the end of talking about this stuff and people are like, wait, I had a question 20 minutes ago. I don't remember what it was. So stop me during the presentation. Cool. So without further ado, Kubernetes. It is a system for managing microservices, containerized microservices made up of microservices. So it is turtles all the way down. Hopefully by the time I'm done here, most of these words will mean something to you. Cloud might already, but there's a lot of cube floating around here. And so hopefully I can do a decent job of explaining how this stuff is all structured. And then dive into a quick little, exploring a live Kubernetes cluster. So I'm going to do a quick crash course on containers. Quick poll of the room. How many people have experience with containers? Should I spend a lot of time there? Should I gloss over it? Wesley, let me know how many people are raising their hand.
Looks like 50%. Also,
Okay.
getting the Kool-Aid Man sticker.
I didn't mail you any? Cool. Wesley, I'm gonna mail you a bunch. So bring them to the next meetup. I got like 300 of them in a file cabinet under my desk. So
yes,
sick. I will, I'm gonna, hold on. We have to pause so I can make myself a note or I'll forget.
I'm sending it in Signal. Don't worry.
Oh, sick.
You bring them here. That's what I'm doing.
Yes. I'm gonna mail him a couple hundred. So if you don't get him, and he shows up just covered in them, I did what I could.
Yeah.
So everybody loves stickers. Cool. So I'm gonna I'll do a 10,000 foot overview on containers just so we know what we're working with, what Kubernetes is, what it can't do, and then some of the kind of like objects, the buzzwords and keywords in a Kubernetes cluster. So containers, as I'm sure people with more tenure and experience in this field know, deploying apps sucks. You have to deal with dependencies, turning over servers, spinning up stuff like that. VMs made things a little bit better. And then whenever I talk about containers, there's always somebody who comes out of, left field with like, well, BSD had jails years ago. Yes. Linux containers have been around for a while. The hill I will die on is that Docker made them popular because they had a cute mascot. That's just, they had a cute little whale, and that's why, they started to catch on more. It was a little easier to run Docker commands versus handling C groups and namespaces in Linux and all that stuff. I stole these diagrams from Docker's website, but if anybody's in the container you may have seen that, like, as of late, Docker is less and less relevant in the container space, such as the struggle of a lot of open source tools is how do you monetize? So containers are meant to be lightweight, standalone. Your base images are based on whatever language you're running, or you can get an Alpine Linux or Ubuntu image or Red Hat if you're paying for it. And they are not a security boundary. They can be more secure, but they're not secure by default. So that's one thing people seem to spout off a lot. Is like, oh, containers are more secure. No, they're not. Don't move to containers because you want to be more secure. You can move to containers if you want to move faster. Sorry, just pulled up the chat. Andy, you're exactly right. Docker had great tooling. That was, and they still do, but they've been usurped by some other stuff. So quick example, this BusyBox Docker file on the left is rather simple. This Maven image is used for running Java builds and such, and you can see it's really, really verbose and complex. So you can be as, simple or as intense with containers as you want to be. All right, cool. So what is Kubernetes? Came out of Google in 2014, 2013. They based it on their learnings from their internal tools, Borg and Omega. Borg is a Star Trek reference. If you've ever wondered why the Kubernetes wheel, the helm, has 7 spokes, it's because of the Borg 7 of 9. I'm not a giant Trek person. That's the only Star Trek fun fact I have. So hopefully that means something to somebody in the room more than it means to me. But they actually donated this project to the Linux Foundation. If you've been in and around the Kubernetes space or heard of it, you may have heard the CNCF acronym tossed around. That's the Cloud Native Computing Foundation, which is a part of the Linux Foundation. And basically Google said, hey, we built this kind of cool thing. Do you want it? And the Linux Foundation was like, I don't know what you want me to do with this. So they created a whole separate division to handle Kubernetes and Prometheus and all sorts of other cloud native tools. So it's basically just a big marketing org. But that makes sure that open source developers get paid. So that's really important. So, that's the only negative thing I would call out about the CNCF. It's another business. Docker and Kubernetes are not the same thing. when Kubernetes came out, it could only run Docker containers. These days, it runs fewer and fewer Docker containers because Docker engine, when it came out, was not compliant and didn't become compliant with a lot of more unified container specs. There's the Open Container Initiative to make sure that like you write a container once, you can run it anywhere. And as Kubernetes has become kind of the de facto for orchestration, they've kind of been leading the way in standardizing these container runtimes. So you'll probably hear the words, if you start poking around the Kubernetes ecosystem, either Cryo or Containerd. Those are more modern, container orchestration platforms, but they're not as friendly as Docker. Docker files are still really, really easy to write, generally easy to read and follow along with. Cool. So what doesn't Kubernetes do? I will say limit supported applications. You can run any containerized application. It depends on if you're running Windows. Kubernetes does support Windows, just, with every caveat under the sun of, running Windows versus Linux, but you can do it. It works. And like most platforms, it doesn't do anything to deploy automatically, doesn't build, doesn't, provide a database for you. It doesn't dictate logging. You can install all of this stuff on top of Kubernetes. And a lot of these things are set up if you use a managed Kubernetes provider, GKE, EKS, Azure Kubernetes Service, DigitalOcean, IBM, pretty much any major cloud provider has one. And as someone that has spent years running Kubernetes clusters, people always ask me how I feel about managed services. And I love them because I have had Kubernetes clusters fall over. I've had, databases split brain on me in Kubernetes, and it is not a late night page that I want to get anymore. So if I can make that somebody else's problem, if that can be Google's SRE's problem and I can just run my apps, great. So definitely not against managed services for Kubernetes. It just depends on how many engineers you have to run this stuff and how many knobs you want to twist. Cool. All good so far? Any questions?
Looks like we're good on questions.
Sick. Moving on. Cool. Like a lot of modern DevOpsy tools, Kubernetes config is declarative. You can imperatively run containers on it. I can run commands like, kubectl create, image nginx, and it can run the systems that I want. But like a lot of like provisioning tools and things like that, you basically give it your declarative, shopping list, and Kubernetes components run a control loop to basically say, hey, this is what they've defined and this is what I've got. I've got, 10 backend containers running, one crashes, I only have 9, I need to spin up another one to replace it, and it's not magic. I like to call Kubernetes a dumb site reliability engineer because it literally just tells you, you tell it what you want and it does what you tell it, like programming. It doesn't, it's not Kate's GPT. It's not, artificially intelligent. Now that I say that out loud, I really hope that doesn't exist and no one's hooking AI into Kubernetes YAML. So don't anybody do that. And Kubernetes is made up of a collection of nodes. VMs are what I've got the most experience with. Some bare metal. Everybody that dives into Kubernetes, ends up looking at the tutorials on running Kubernetes on Raspberry Pis, then deciding whether or not they do it. They have no idea what they would run on a Kubernetes clusters on Raspberry Pi. It's more bragging rights, but that's fun to do. You can run cloud on-prem. You can split it up. Have part of your cluster on-premise, part of your cluster in the cloud. Why would you want to do that? I don't know, but you can. Cool. So that's history, background. Going to dive into some of the components of Kubernetes. These first few slides are about the control plane, the actual control loops, API server and stuff for Kubernetes. These are the things that if you start using a managed Kubernetes service you will not need to care about. And so it is nice to be aware of them and then, maybe forget about it. But unless you're running your own clusters, but it's a nice to know that, what these services kind of abstract away from you if you go the managed route. So the first thing you need is a container runtime. Back in the day, when I first wrote these slides, Docker was at the top of the list. It's not there anymore. Containerd and Cryo are the kind of go-tos for running containers. You can run Docker. It takes a little extra doing. I don't know if anybody in the room was involved in the cloud native space years ago. Does the name CoreOS mean anything to anybody? Anybody want to pour one? Oh, sweet. Hell yeah. Pour one out for CoreOS, man. So they had.
Do what, Aaron?
At least we got flat car.
We got flat car.
Yep. Flat car's good. Yep. What is that? Kinvolk?
Fedora Core,
they got
the successor.
Mm-hmm. Yeah, flat car was Kinvolk, right? They're part of Microsoft now, I think. Could be wrong. So, what's that?
I don't think they're dead. They're bought by someone else now.
Daniel, you said Fedora?
CoreOS was bought by Red Hat and is now so CoreOS is now synonymous with Red Hat CoreOS, and then the upstream is Fedora CoreOS, and is actually used as part of OpenShift now.
Yeah,
makes sense.
There's no plans to work on the CentOS equivalent.
There's no CentOS anymore.
CentOS streaming.
I'm sure Rocky's working on something.
Cool. So you could theoretically mix and match container runtimes for Kubernetes. I wouldn't do it, but you could. So that's the first thing you need. Again, running a managed service, you're probably going to use Containerd. They'll make that decision for you. I know that's what most modern GKE clusters are using. So the control plane, these bits are what make Kubernetes do the thing. The cloud controller manager is less of a thing these days. There was a push recently to kind of pull a lot of provider specific code out of Kubernetes because it was a Google project originally. It spoke GCP rather natively, but to make it more open source and cloud agnostic, the code is still there. It's just in separate repos. It's more, kind of plugin oriented, things like that. So before I move on, cool. All right. So the most important thing here is our controller manager, the API server, and the scheduler. And basically these all work together to let Kubernetes do what you want it to do. When you run your kubectl or kubectl or kubectl, however you want to pronounce that word, commands, it goes to your API server. If you have any auth set up or things like that, you get authenticated to your cluster, auth-n, auth-z. Your scheduler just runs a loop and says, hey, how many VMs do I have? How many CPU cores? How much memory is available? And then your controller manager watches your cluster and says, hey, somebody just deployed 10 more backend containers and I need to scale up, or, vice versa. Excuse me. So those are your three main core control plane components, formerly known as the as master nodes. I think control plane is the word that the Kubernetes community has settled on to move to some more inclusive language there. But you will still see worker nodes, master nodes. I don't think there's slave node floating around there, but just so you know, if you're poking through docs and tutorials and stuff like that, they didn't update all the docs back to the original creation, but most of that stuff's been updated to reflect some better language. So on this slide too, there's also this little box called etcd. I don't know if anybody's used this in the past. etcd is basically little piece of software that's responsible for the state of your cluster. It is a key value store that just tracks how many replicas of a certain container are running, you know, all sorts of stuff. For every API server call you make to Kubernetes, there's probably 6 or 7 calls to etcd back and forth. Basically, if this falls over, your cluster's API won't know the state of the things running in the cluster. And if it gets split brained, you know, you can run kubectl commands and get different counts back for every, you know, different command you run if you get kind of round robin through etcd. So when I found out that I could use a cloud provider and have etcd be somebody else's problem, I loved it, because, you know, I don't know if anybody has used this in the past, but when etcd moved from v2 to v3, there was no migration plan. They gave you a bash script that you ran and piped your etcd output to it, and you just crossed your fingers and hoped that everything worked. So that was terrifying. Don't ever want to do it again. It's a really slick piece of software, but it's, you know, it can be fragile. Was this the right decision for Kubernetes to use? Who knows? But it was one of those, as all of us in tech can relate. We made a decision at the time, seemed like a good decision, can't undo it. You know, here we are. So, yeah. Probably Aaron, one of the last vestiges of CoreOS, definitely. There's actually the folks from I think Tencent Cloud and Alibaba Cloud have done some wild stuff with etcd scalability. There are soft limits in etcd's docs that says you can't go over 50 nodes, and then there are some engineers running, you know, cloud systems that are like, watch me, here's 750. So you can do it, but you need a whole team to manage it. So not going to happen. Cool. Next up. All right. Any control plane questions before I move on?
Doesn't look like it.
Neat. Sweet. Cool. So next up are worker nodes. These are separate VMs that are where you run your applications. They do not have to be separate from where you run your API server, controller manager, you know, like the control plane nodes. But it's actually almost kind of harder to make it do that. You don't kind of, unless you're running like a single node cluster on your laptop for monkeying around, it's going to be separate. And there's just a couple pieces of software that run on these nodes to make it do the Kubernetes things. You know, there's a whole bunch of other stuff. You know, obviously you need your operating system and all that jazz. But the oh, okay, there's still animations. There they are. Cool. Worker nodes, where your containerized services actually run. So on these little boxes, you have your container runtime, Docker, Containerd, Cryo, Rocket, if CoreOS was still around. And you have your kubelet and your kube proxy. The kubelet is this is a piece of software from from the Kubernetes community that basically talks back and forth to your API server and reports the status of your nodes. How many containers are running? What are they doing? Is anything being spun up? It's constantly reporting back to the API server, which is then being pulled by your scheduler and controller manager to find out, hey, I need to run a front end container. Where can I run it? Gets put on node number 1, the kubelet hands it over, and it communicates to your container runtime. It spins up your container. Kube proxy is just what it sounds like. It is a proxy that allows all of these containerized services to communicate both on that individual node, and then Kubernetes will see by default your node pool as kind of like just a big containerized overlay network, so they can all your containers can talk to each other over DNS, or you could hard code IP addresses, but they're rather ephemeral, so I don't recommend doing that. But the out of the box, your containers running can see each other. It's all in cluster DNS, which is generally pretty decent for communicating, but can be a scale problem. The Kubernetes community has started using core DNS as its as its DNS provider, which seems to scale pretty well. But if you're running thousands and thousands of containers, you might have issues. It's always DNS, as I'm sure we always know. And then before I move on, I wanted to touch on the Cloud Controller Manager here. Like I said, this architecture has changed a little bit, but Kubernetes allows you to communicate with your cloud provider under the hood, or your on-prem data center stuff if you've configured it, and basically, if you're running some sort of auto scaling and you need your cluster to spin up extra worker nodes, that's the piece of software that's going to talk to AWS, GCP, Azure, insert cloud provider of your choice here, and spin those things up. If you have containers that need storage volumes, it's going to go to EBS and say, hey, give me a volume. So it's, it's cloud provider specific code to manage, cloud resources under the hood, generally storage and VMs and some networky things. But some of that gets abstracted away by certain platforms. So basically covers what I just said. Kubelet ensures containers are run, works with the container runtime. Kube proxy acts as a proxy and load balancer, routing packets to containers, and then you need your container runtime so you can actually run your containers. Just a few other things before I move on, just to that I wanted to call out. There's been a lot of traffic, pun not intended, but accepted, around the container network interface and all sorts of containerized standards. There's no one way to run networking in Kubernetes, but there has been the introduction of the CNI, which basically means if you use this library and this spec, you can manage your networking in Kubernetes with a bunch of different options. They're all going to be compliant. There's the container storage interface and all these things. We're really moving towards a unified kind of compatibility layer with containers. And then DNS, everybody knows what DNS does, allows for discovery of objects in your cluster. And then Grafana and Prometheus are two of the big open source tools in and around the logging and monitoring space. Every cloud provider has their own. There's also, New Relic, Datadog, all sorts of other honeycomb observability tools that you can run in your cluster. Awesome. All right, so that is what Kubernetes is. Those are your control plane and your worker node components. That's great. If everything's working, you don't really have to interact with them a lot. This is, I think, where if anybody's Kubernetes familiar, we're going to get into some of the buzzwords you may have heard floating around, including the word pod, which is something that people hear in the Kubernetes community a lot and go, what the hell is a pod? So I'm going to cover all of that stuff. Any questions before I move on?
Looks like we're good.
Cool. All right. So I've been saying the word container a lot. Kubernetes does not care about that word. It does not know what that is. The smallest unit in Kubernetes is a pod. I forgot to put a Tide Pod little sticker on here. That's neat. So a pod in Kubernetes is one or more containers. They are all in the same storage network space. It's all namespaces and C groups under the hood. They can all communicate over localhost. And so pods will be the buzzword that will probably do the most for you in the Kubernetes space. Why would you want to run multiple containers in a single pod? It's pretty much, it's not recommended to do like front end and back end together because they are tightly coupled. If your pod crashes, you lose, like if you delete it or it gets, if it gets killed, you lose your VM or something, you're going to lose everything in that pod. But there are use cases, maybe like a networking proxy or something like that. Apparently I'm thumbs upping. Thanks for that, Zoom. So there's use cases for like a network proxy, or you have a front end container that serves some web content, and you have an auxiliary container that syncs something from an S3 bucket, syncs your content or something like that. Kubernetes has the ability to run certain containers at the startup of a pod, maybe you need to come in and make a few config changes or something like that, and then start up your regular container. So there's a whole slew of best practices around architecting and grouping containers together, but it's pretty much up to your engineers. Deploying a single pod, I could take this YAML spec and throw it at a cluster, run Nginx. It provides no recovery. If that pod crashes, Kubernetes goes, oh, I tried, sorry. I don't know what happened, but it didn't work. It doesn't restart it, doesn't bring it back up. There are other levels of controllers that will do that, but unless you're doing a tutorial, you generally don't ever want to deploy a singular pod. You get no life cycle there. Quick side note, all this fun YAML stuff supports things like labels and annotations, are purely key value pairs for organizing things. Folks that have used Kubernetes tooling for a while might see certain annotations. Apps can inject arbitrary values into annotations to report back information. Labels tend to have some more concrete use cases, such as networking and things like that. But it's how a lot of information is logged in and around the Kubernetes space. You'll see, like in this case, Prometheus has logged some config there, and its application will read that for whatever reason. You can update timestamps, ownership. I've known people that put like URLs to run books. So if you're looking at Kubernetes stuff that's unhappy, and you've gotten paged, you can, have an annotation that says runbook URL, and it links you to, a Confluence page or something. So the sky's the limit. Taking a step, kind of zooming out here, there's no distinction between what's running in your Kubernetes cluster. By default, there are these things called namespaces, which they use the phrase virtual clusters. I don't know if I like that word, but it is a logical way of grouping resources in Kubernetes, and that's all it is. By default, you'll see, you have like your default namespace. Kube system is where those control plane components run, and then Kube public was originally intended to be where you ran your public things, like, if you needed to expose load balancers or things like that. But by default, namespaces have no restrictions. I can look at something in another namespace. My pods in one namespace can talk to another. This is another one of those. It all depends on how you want to run Kubernetes. I know when I worked with Wesley at Crunchyroll, we had a namespace for every kind of like app team. And then that allowed us a boundary to kind of scope access control around. If you're just farting around with a tutorial, you can deploy everything in the default namespace. You generally don't want to put anything in Kube system, because that's where all the things that make Kubernetes do the thing run. So you want to kind of stay out of there. But this is one of those questions, much like grouping containers together in pods. If you start a Kubernetes journey, or you're scaling up or something like that, you want to figure out your namespace structure earlier on. But naming shit is hard. So however you want to break it up. It's back in the day, naming environments or something like that. This is just another thing you get to figure out how to name. So by default, like I said, they don't provide any sort of restrictions, but they are something you can anchor role-based access control on, things like that. It's very common to give people like read-only access to other namespaces. And then if they're on some sort of app team, give them, super user access to like the backend namespace or something like that. So, you can have one big namespace, you can have a bunch of smaller ones. However your application decides it needs to be architected. All right, next up. So pods are ephemeral. If your app crashes and you're running it with one of the higher level Kubernetes controllers, Kubernetes will restart it, but there's no guarantee you will get the same IP address. You shouldn't be hard coding IP addresses if you can avoid it anyway. you know, pods and containers crash, VMs get replaced, you know, you scale up and scale down. But this is where DNS comes in. Kubernetes under the hood handles its, you know, the assigning of an IP address to each pod, but there is a DNS entry you can use that you can hook onto and do your networking that way. So even if you're running a single pod, you know, it's your one front end pod, there is another layer of abstraction that you can run so that pod can come and go, but you can still network. And we'll get to that in just a sec. So, oh, cool, I skipped something. Deployments. All right, so continuing the theme of Kubernetes having bad naming things for things, deployments are a Kubernetes object. So if somebody's talking to you about Kubernetes and they ask you, how's the deployment? Are they talking about like the overall, like, how's Kubernetes going? How are we rolling out? Or are you actually asking about like a specific deployment? I don't have a better name for this, but I just don't like deployments. So deployments are an abstraction that, as you can see over here on the right, wraps pods. So every one of the 4 pods, there's 4 replicas here, will be exactly the same. You don't run a deployment of different pods. It's just how many of this version do you want to run? They'll have the same config, same memory and CPU limits, same image, all of that stuff. And so all of that to say, if your application can't run with multiple replicas, don't do this. There is no magic that will make Kubernetes kind of like handle all of this. You know, it will spin up 4 Nginx. Nginx is a bad example because it'll be fine. But if your application is meant to run on a single server and you run 4 containers of it, you know, how does it stay in sync? How does it get its information? That's all up to you to architect. There's another fun Kubernetes buzzword called a replica set, which is the layer between a deployment and a pod. You don't really need to know a lot about replica sets. It's just basically this yellow highlight here specifies when I want to upgrade this or update this Nginx deployment. My max surge means I can have one additional pod to start up, and I can have 1 pod unavailable, either shutting down or starting up as I roll out this update. And that's just how deployments handle it under the hood. It spins up a new replica set. It balances them out, and there's kind of some inbuilt logic there, so that if you know your containers start crashing and not coming up, you know, Kubernetes can roll them back for you. So it's this is the layer of abstraction you're generally going to work with is the deployment. You don't want to deploy single pods. You can deploy single replica sets, but generally 90% of the time you're gonna use deployments. The other 10% of the time are going to be one of these 3 ways. Anybody that's been in the Linux world has run daemons, however you want to pronounce it, on servers. A daemon set is just what it sounds like. If you have a bunch of logging collectors on a 10-node Kubernetes cluster and you have 10 replicas, how do you make sure that when you add another VM, you get another replica of that logging collector? That's what a daemon set is for. It will put one of these pods on every node in your cluster. Great for networking, proxies, logging collectors, metrics collectors, anything that you need one of everything on a node. Also useful for DNS. I know a lot of people that run DNS as a stateful set just because then it's easier to scale up. I'm going to skip to the bottom. Cron jobs are just what they sound like. You want a pod that does a specific thing on a cron syntax, run it in a cron job. Kubernetes will start it up on, you know, whatever your interval is. These are generally pods that perform a task and then exit. You know, it syncs some files, it runs a report, it does something. It's not a long running, it's not your front end, it's not your back end, it's your, you know, your auditing task or something like that. And then a stateful set, back in the day when Kubernetes first came out, running stateful workloads wasn't as common as it is now, but a lot of that ephemerality of pods under a deployment is kind of removed from a stateful set. They don't often automatically update. You have to kind of go in and either manually delete the pods. You almost handle the rolling update. I spent a lot of time running Cassandra in a stateful set. And it's meant for things with persistent storage, you know, often databases, things like that, caching layers, Redis, stuff like that. Next up, how do we talk to all these things? Another one of these fun names for Kubernetes. Kubernetes services are another object. These are the in-cluster load balancers that sit in front of your groups of pods and allow you to communicate. So you never have pods communicate with one another. They always go through a service. So even if you have one replica, one pod, you always go through that service, because then behind the scenes, if you're upgrading your container image, you're scaling up, you're scaling down, Kubernetes does the heavy lifting of parking the IP addresses behind that service. So you always route traffic, you know, it's a load balancer. You always route traffic through your load balancer. You don't go direct to the server. You can, but you shouldn't. You lose a lot of that kind of life cycle and routing. And services are used to target pods. They do that with a label selector. I talked about labels earlier. You'll often see this like app, my app front end, app back end, app. It's not a requirement. It's just kind of a Kubernetes convention. And you can use label selectors to do some fun things in Kubernetes with like a blue-green deployment. You could have two deployments behind a service. One of them's got a slightly newer image, and you could kind of use that for a blue-green rollout or something like that to fail over to a new version. There are a lot of managed services that will do this for you. I know Spinnaker takes advantage of some stuff like that to do automated blue-green rollouts. I don't want to dive in too much on this because I want to leave time for questions. The long and short of this is there are multiple types of services in Kubernetes. They can expose an external load balancer on your cloud provider. You can have it open a port on every VM so they can communicate. You could just create a service that's a CNAME to an external cloud resource. I know I've done this a lot with RDS instances. That way, you know, I just have a nice friendly name in Kubernetes, and then AWS can handle that ugly DNS name for its RDS instances. And then lastly, before I open it up for questions, is storage. You can mount, just like containers, you can mount volumes in Kubernetes pods. These can be used, all the containers in the pod can read that volume, useful for config or storing any sort of data that you want. A standard volume is ephemeral. It'll go away when you delete your pods. And then in comes in persistent volumes, and this is about as in depth as I'll get for now, but this is very common in stateful workloads. You know, you store your data in some sort of volume, and under the hood, these are generally EBS volumes in AWS or whatever Azure's or GCP's volume abstraction is. And so, yeah, I just have one more thing. Config maps and secrets, key value pairs for configuring containers. You'll find on your container journey that you want to make things more and more configurable, you know, specifying environment variables, things like that. This is just Kubernetes abstraction on how to handle that configuration to the point that, you know, you can keep your container running and change some variables and stuff like that and not have to do an entire image rebuild and things like that. Secrets are the same thing. They're just encoded in the cluster. Notice what I said there? I did not say they are encrypted. They are base 64 encoded. So anybody that knows how to pipe something to the base 64 command in their terminal and has the access to read those secrets can get all the values. So they're not so secret. I recommend using some sort of other tooling to handle that. You know, GCP Secrets Manager, AWS has a secrets tool, and then, you know, some sort of third party to connect them to your Kubernetes cluster. So I think, yeah, I have, now I'm on to Q&A. I hit you with a lot of stuff there, I know. So what do you guys want to know?
Michael, I think you were first.
No, whoever goes next.
Good.
So this is great. How do you extract it? Helm. Well, no, that might be new or old. How do you extract it not in the best way?
Did you get that?
I heard, how do I abstract it? And then the word Helm.
Yes. He's just trying to list off all the nautical themes, abstracting away Kubernetes, though.
Yep.
Is that correct, Michael?
Yes.
Yeah, so Helm is a tool that came out of Microsoft. I'm going to stop sharing. Helm is a tool that came out of Microsoft a while ago, which is it's called the Kubernetes Package Manager. It is a way of templating and packaging up all of that YAML that you see for Kubernetes things. It's really great. Helm 2 used to have a component that ran in your cluster and did all of the activities that involved installing applications, which basically meant you had a little user floating around your cluster that had root access, which was terrifying. So Helm 3 was rewritten and it acts with your permission. So if you're running Helm commands from your laptop, it assumes your role. It can only do what you do. It makes it easier to handle service accounts and things like that. It's a great tool, but yeah, to expand on that, it's one of those like, do I use Helm? There's a tool called Customize. There's Argo. There's so many other, it's like, how do you deploy in Kubernetes? It'd be easier to, you could pick a nautical word and it's probably some sort of Kubernetes tooling.
Yeah.
Kubernetes means Helmsman in Greek, by the way, if anybody's curious. I don't know why.
Say that again.
Helmsman. That's what it in Greek, which is why you will see all of these, nautical themes.
Yeah, I support a NetApp filer, and what I see on the filer all the time is Kubernetes volume sort of creating storage and storing storage as they see fit. And how does that work?
There's a few ways to configure this. When you have any of your containers in Kubernetes working with some sort of storage, you can, if it's coming from, if you're talking to a cloud provider or like, NetApp or something like that, if you give these Kubernetes systems permission to create volumes and cycle storage and things, it will just do that. I have found in the past that like you can run into issues where developers think they need a 200 gig volume and they start creating them. And then by default, you don't clean them up. And so all of a sudden you've got 400 EBS volumes and you're paying out the nose for your storage. On the flip side is like, as an admin, what's that?
Welcome to my Monday mornings.
Yeah, right. Yeah, definitely. And like on the flip side, as an admin, I can configure that and say, hey, no, your pods can't create volumes automatically. You do in cluster permissions or things like that. But that means every time somebody needs some sort of storage, they have to come to me and I have to like provision it for them and set it up. So it's that like slippery slope of, how do I prevent them from burning through all of this? And there are tools outside in the Kubernetes ecosystem outside of like in-tree Kubernetes that allow you to stop that stuff from happening or clean things up. You can write your own stuff in-house.
We have a lot of very good discipline about cleaning stuff up.
Yes, yeah. That's honestly one of the go ahead.
We create volumes that are sort of just the right size, and they're always 93, 94% utilized. And when things start ramping up a little bit, we just, not that we care, because it's sort of goes make as much storage as it wants, but we see just random intermittent alerts for 96, 97% storage.
Mm-hmm.
And we know that they're random and arbitrary and are completely meaningless. So we're trying to figure out how can we sort of buffer that so that the amount of storage that NetApp gives it is always a little more than it thinks it needs. And so we stop sending sort of random alerts that we know are meaningless to start with.
You mentioned you had some test clusters. Could you show us PVC real quick?
Yeah.
Yeah, that's for your question.
Okay, all right. Well, I don't know.
While you're doing
What did you want to see specifically?
A PVC. Managing net assets.
Yeah.
Yeah.
all I hear is going to Lowe's or Home Depot right now.
Yeah,
That's the problem.
persistent volume.
Awful.
Yeah, I know, right, Ben?
Just thought of his speed marketing. The request for.
Seth, if you could zoom in.
Yeah, I get it. Now,
Yeah,
I'm tracking what the
Thank you.
context is now.
Yeah, sorry.
That's okay.
So, side note, I am not typing kubectl every time I run commands. The first thing I do when I get a new laptop, not the first thing, is I alias that to K. So I don't like when people do a lot of demos and they have a whole bunch of aliases and stuff. That's the only one I have. I don't want to type that all the time.
Can you zoom in a little? A lot of us are using workloads. Thank you.
How's that? I got like one character on my monitor right now. No, it's fine. It's fine. So let's see. So just to talk about other things, kubectx is a tool that allows me to list out all of my clusters that are running and switch between them. So you can see I have like some of my work clusters here, and then I spun this one up on GKE earlier. Oh, it's running Nginx. Neat. I don't think I have any volumes configured. Hold on real quick. So somebody else ask a question. I'm going to find a YAML snippet so I can create one.
Andy wants to know, is flagger a nautical term?
I don't know.
Yeah.
What's
it's semaphore.
Oh, okay, yeah.
Oh, okay. Got it.
Now you hate C.
No. I've seen them before. It just didn't cross my mind.
I was just thinking of traffic lights.
And thinking about Kubernetes, how do OpenShift and Rancher play? Are they alternatives to Kubernetes, or do they work on top of it?
Yeah, they work on top of it, and they are like much like Red Hat paid support. So if you're running your own stuff, it's nice to use, nice to have some sort of support to help you out, but less and less important if you're running it like on a managed provider. Rancher does a lot too with like running Kubernetes locally, which is nice. But I have thoughts on Rancher that I won't. What'd you say?
I say it sucks out language.
You're
Every time. All right.
over there loves it.
Does anybody here work for Rancher or associated with Rancher in any way? No? Great.
Oh.
Awesome. Every time a new open source Kubernetes release comes out, engineers from Rancher, especially like the CTO, freak out on Twitter. Like, I don't know if you guys are aware, Kubernetes cuts a release every 4 months. Like, there's a feedback loop, there's a process, you can open issues, and every time it comes out, they're like, what do you mean? It's completely different. And it's like, well, no, it went from alpha to beta to GA. There's a whole life cycle. Like, the development cycle in open source Kubernetes is one of the best I've seen in an open source community. My sample size is not huge, but it's just like every time something changes and they're surprised. And I'm like, where have you been? Like, this is we're on 1.26 already. There's been 26 minor versions of this so far. So, I don't understand. So I think I found something that'll work. Let's see. Neat. Okay. So if I share again. So I think I configured this GKE cluster properly to work. So I have this is literally from the GCP demo. So it's going to create a persistent volume claim, which means it wants 30 gigs of storage, standard read write once, and it's going to be tied to this pod, which is running Nginx. I didn't touch on it, but you can specify limits and for memory and CPU and stuff with Kubernetes and have it take, action, restart pods, things like that. So when I mentioned kind of like provisioning your own storage, like as an admin and like making it available to, developers, you could create a bunch of persistent volumes manually, tie them to some sort of storage under the hood. And then when a pod comes along with a PVC and says, hey, I want something that's 30 gigs, if it doesn't have anything available, that pod will just sit pending forever. This cluster out of the box should have auto provisioning on. So could not find expected what? : Ooh, all right, let's see. We're gonna find out. Lost my, there we go. I don't know, looks right to me. I don't know how this stuff works.
Are you on a 4K monitor?
Yes.
I am.
90.
How's that? It's just the same YAML. I just want to figure out line 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Storage.
Thing right there? Yeah, that separates multiple documents in a file. Thank you.
Yes. Very, very common YAML convention. You can just have all of your YAML in one big file, and then just that line will separate it. So it doesn't like it. Why doesn't it like it? Oh, sweet. I didn't do anything. Neat. So if we get pods, we will see these existed. You see my terminal, or are you just seeing text edit?
You see terminal.
Sweet. So these Nginx ones I created earlier. So this is a Nginx deployment I created earlier. It has 2 replicas. They are the exact same container. They just have different, automatically generated names. There is one container out of one running. If there was multiple things in there, it would be like, 2 of 2 or things like that. I can scale deployments, replicas, 6. I can see them all starting up. I might hit a limit because my cluster might not auto scale. But if I look at this one, let's scale that down. I don't want to pay for that. If we look at this one, we look at the YAML under the hood, we can see a whole lot of metadata that Kubernetes injects automatically. This is the stuff we specified. What is our image? What's it called? You can, we're exposing a port here because we want to network to it. It mounts some volumes. There's a whole bunch of status. I'll stop moving when I find the part I'm looking for. Yeah, so all the status stuff, Kubernetes will tell you where it is in its life cycle. And if I do PV, so the persistent volume, so we can see, zoom out. I don't like the way that's wrapping, but we'll deal with it. This isn't wrapping very friendly, but standard read-write once is our storage class. These are cloud provider specific. So just like whatever your EBS, or in this case, GCP config is, generally you can only mount your volume to one VM at a time. How old is it? What's my capacity, access, reclaim policy? If I delete this PVC, do I delete the volume, or do I hold on to it and then somebody has to go through and manually clean it up? That depends on how, resilient you need your data to be. Status, it's bound to a pod and it's bound to this volume claim. And we can see it basically has all the same specific stuff. And I did not have to create this persistent volume because my cluster is configured with auto provisioning. So if I have my computer lock up on me, oh, my Chrome froze. Neat. All right, let's zoom in. If I do, what's the GCP storage thing called? Show me here. Okay, cool. So GCP is really good about making Kubernetes things show up in the console. So like in GKE, I can go look at my storage, and this is the volume I've provisioned. I can see all the info here. What's the actual volume under the hood? So I could go see it and look at the spec. And then theoretically, I could, I don't think there's a service for this. No, so if I do this, I remember my syntax here. Is that it? Cool. And then if I do 80, yeah, so Nginx doesn't like me, I can't get in, but I can hop in there and look around. And then if I do pod demo, where's that volume mounted? Did it say? Okay, so we can see here, this is where in the container, that actual volume is being mounted. It's calling the claim here. So I could theoretically, all right, so if this works, hopping in the container, you're not supposed to do this. Where was that? Anybody remember where that volume was mounted? I don't.
Nginx HTML, I think. Yep.
So, yep, cool. Yep, so if I do share Nginx, NCD HTML. So like there's probably nothing in here. Yeah, there's just a lost and found, but this is in that volume. And I could have another container in this pod start up and populate this volume, and then have Nginx take over, or do do something like that. There's one other thing I was going to say. Oh, everybody always says that containers need to be idempotent, and you should never exec inside them. Yeah, that's like best laid plans of mice and men. I exec into pods all the time to take a look around, because like people aren't writing good logs. It's just, it barfs everything to standard out. So, if somebody's not writing good logs, then you're still going to want to get around in there and poke around. It's still dangerous, but you can see this one. It got mad that I went in there. So you can see just the Nginx logs right here from everything starting up. Does anybody want to see other stuff while I'm here? I know I'm over time, but.
Questions from the room? Michael?
First of all, opinions on microcates, and can we see your cat?
Opinions on microcates, and he wants to see Misha.
I haven't used microcates a lot. I've heard good things. I'm not opposed to it. Is this the, oh yes, this one. This is Canonical's thing, right?
Yeah, I'm just used it all.
I have not used it recently, but I am all for stuff like this. Like Kubernetes is super complex, and it scared the hell out of me when I started using it. And if people want to, like, even as I'm talking shit about Rancher, like if people want to wrap it up and make it more user friendly, like please do. It's, I think it only benefits this platform to have more eyes on it, more automated solutions, things like that. Like I've run Kubernetes, I've got the bragging rights. Now I don't want to run it anymore. Now I want to have GKE run it, so then my devs can deploy on it, and I can focus on like the CI/CD and the deployment pipelines and stuff like that. I do recommend people understand it. There's some really good like tutorials out there that it's one of those things where it's like, if you set up stuff from scratch, you realize how nice it is to have somebody else do it for you, you know? So, and then, yeah, hold on, let me turn my background off. Da, da, da. Hey, hi, come here. Come say hi. Oh.
Maine Coon?
Big man. Nebelung. So basically a long-haired Russian blue. Hey.
That's for a talk.
Wow, Michael.
You kidding? Come on.
Well, he ain't a kitten anymore.
Everything's a kid.
No, he's big man. Gonna be 6. Oh, he just hangs out on my desk all day. Right, bud? Yeah. So cool. Anybody else? I want to know anything else?
Oh, well,
answer any other questions?
You're in the Bay Area?
Yeah.
What
yeah.
part?
East Bay, Alameda.
Yeah, I get out there. I've got a bunch of cousins in the South Bay area. Get out there
nice.
regularly. Yeah. I was just out there.
I'm just south of Oakland. So if you ask anybody truly in the East Bay, they're like, you're practically in San Francisco. If you ask anybody in San Francisco, they're like, over the bridge. God, gross.
Aaron, I think you had one last question.
So kind of a real question. How have you found the documentation to be just in general around Kubernetes?
Fantastic, because I helped write it. No, so one thing that I love about Kubernetes is if you are shipping a new feature, a change, anything as a part of Kubernetes, documentation is required. It does not matter if your code is complete and by some miracle completely bug-free and will never break. If you did not document it, it does not ship. As a part of the release team, there are different like subsections of people that help out. And I got my start on the docs team because I am a college dropout. I didn't learn to program until, a few years ago. Like, this is all an accident for me. But I can write docs. I can, read tutorials and things like that. So that's one thing that like really impressed me about Kubernetes is if something's moving from like alpha to beta, sometimes the doc changes just change from alpha to beta, like change one line. But especially if it's like user facing, there is a whole standardization process, a like style guide for language and stuff for Kubernetes. There is could always be better, 100% could be better, but like growing contingent of docs team members outside the US that are like translating into, like I think we had like Urdu docs go live recently, Brazilian Portuguese, very large contingent of developers in China. So there's multiple, forms of Chinese docs. So I always tell people to go to the official Kubernetes docs because that is like reviewed by the Kubernetes team. After that, your mileage may vary. Like if you go somewhere else, you're like, this doesn't make sense anymore. This isn't how it works. Cloud provider docs can be pretty decent, but like when in doubt, I always point people to the Kubernetes docs because those are the ones that like generally are pretty good. And if they're not, and open a pull request. You know what I mean? Like, and this isn't me being like pull request is accepted. I don't mean it like that. Like there is a documented process for getting involved in the Kubernetes community, and like docs is one of the best ways to get involved. Long answer to a short question.
I've got one. Of the different cloud providers that support Kubernetes, which has been your favorite? Like, which has been worked the best or has the most features?
So GCP, I think, will always lead that because when Kubernetes started, a lot of the some of the ways GCP networks was built with Kubernetes in mind. The one thing that's weird to me about GCP, and I'm still getting used to it because I was predominantly an AWS guy before this, and this is not just true of Kubernetes, like GCP is really big on like no ops tools. Like you just throw code at it and it does the thing, which is great. But then I'm also like, I only checked 2 boxes and selected a value from a drop-down menu, and now I have a fully featured Kubernetes cluster. What did I do wrong? Like I want to be a little more in the weeds about it. I have watched over the last few years EKS get a lot better. It was behind a lot in the because Kubernetes only supports, I think, the last 3 minor versions. So they were like,
Yes.
they were behind, and they had devs that
Kubernetes service.
worked on it.
AWS. Sorry, continue, Seth.
Sorry, yeah. Yeah, AWS, EKS. I've watched them get a lot better. And you know, Azure too. I know a lot of people in the Kubernetes community that work full-time at Microsoft, and their job is like building Azure Kubernetes service. So I think GCP for the foreseeable future will always have like the advantage there, because there are still a lot of the core devs working there. But there's been, I mean, it's been 7 or 8 years. There's been turnover. You know, people have stepped down from the project, and people have started to spread out a little bit. So I do really like GCP, you know, GKE. I use it daily now. But I like, my biggest thing is that, excuse me, my devs don't need to know Kubernetes. Like, I wrote some GitHub actions that deploy Helm charts. I wrote some templates. You know, on EKS, it was a little more hands-on, which like there are application developers that love that. You know, like where I am now, I'm a post Series A startup, and I can't look at my devs and go, this is Kubernetes. They're like, great, cool. I don't care. I want to click the little button and my app gets deployed. And I'm like, all right, you know. So and if you don't want to run Kubernetes but you want to use it, if you can, use GCP. Autopilot's great. You know, you don't even see the control plane. And I don't work for GCP, so I'm trying not to sound like I'm shilling this. You don't even see your VMs in the console. It is all abstracted away from you. You just run containers on it. And EKS on AWS is getting there. They've got like managed node pools and stuff like that. But when EKS first came out, it created a control plane for you. And then you had to manually edit and apply CloudFormation templates to spin up the nodes. Like, that's what the offering was. And it was rough. It worked, but like, I wrapped it in some scripts to automate it. But now it's great. Now it's one button press. I haven't looked at AKS in a while. But like even DigitalOcean's was good. I was trying to run my demo on there earlier because I had a side cluster project, but it wasn't working. But their stuff's good. Even IBM Cloud has a Kubernetes offering. I'll tell you how I feel about that one off air.
What are your thoughts on Podman?
What are your thoughts on Podman?
My favorite superhero. I used it for building containers for a bit. I really liked it. It's something that I've wanted to mess around with introducing where I am now, but changing people's Docker oriented workflows is going a little slower than I want it to. But I'm really into alternate container building tools. One, because like Docker probably won't be around forever. And they do some weird stuff with their licenses, you know, like Docker used to be free for everybody, but now if you use it in a business, you're supposed to pay some amount of money. So I'm big into Podman, or just using like the containerd tooling or something like that to build images. But that's me. And if I tell my devs, hey, you can't use your Docker files anymore, they're going to tell me to take a, you know, long walk off a short pier.
Same question, singularity.
I don't know what that is. What's that?
Quantum, AI, which one are we talking?
Singularity is, now if you look it up, it's usually an HPC a lot. It basically takes Docker and makes it useful. I mean, for you.
We have a lot of HPC folks in this town. Something about
different paradigm though. Go mark that. It's called Appian now. They renamed it. Talk about those.
Sick. I'm gonna play around with this. This is why I love speaking at meetups. I get to learn about new stuff. I love when people ask me questions and I have no idea what that thing is. I was like, great, now I got something to look at.
Aaron.
I'm gonna sneak in and ask kind of a slightly amusing one. How mad were you when you found out about kubectl explain?
Is what?
How mad were you when you found out about kubectl explain?
Oh.
Apparently very pissed.
Yeah, man. Like
That's
I learned about that, and then I made sure to show everybody. For people that are not aware, like there is a really good, like to talk about how good the docs are, there is a kubectl command where you can specify like an object, and Kubernetes will tell you about it, and it will give you some info and links, and you know, you can be like, explain deployment, you can get info on the fields and stuff like that. And if you know, you sit for the CKA or the CKAD, you can basically use like the Kubernetes docs site, and like that's it. And so it, you know, one of the first things they tell you in all those study guides is like kubectl explain. And I came across that one day and I was like, wait a minute. I had like the API spec docs like bookmarked, and I'm scrolling through like thousands of lines and I could have just asked the terminal for it. I was very angry. I was like, no, damn it.
So why isn't
yeah.
this at the beginning of your talk?
I have no idea. It's not the beginning of the docs. I spent 4 years not knowing about it. Literally doing exactly what you're doing, bookmarking the API docs, which are not pretty, to go try to figure out how to specify this one thing.
Yep. Yeah.
Describe too, because describe gives you info that sometimes is really hard to get.
Yes, definitely. Yeah. I found working with Kubernetes has made me really good with JQ too. Trying to get like the specific field I want, the one thing in that god awful JSON spec. So, but I feel like that's true of anybody in DevOps. They get really good with JQ.
I have one
What else
myself, and I think might be good. This is
cool.
more specific to what we were doing at CR though. When we were doing the annotation files with TerraGrund and Kubernetes and promoting it up, were those annotations with if statements EF specific, or is that actually like through Helm?
I think that was through Helm, because Helm has a syntax for like looping and conditionals.
Yeah.
Which is so that was through Helm, which is actually really cool, because then you can specify like, you know, if local or if dev, and it pulls in different values, or I think in our case we were rolling out the service mesh stuff for a bit, the Istio thing. So yeah, that was Helm specific.
Okay. Awesome.
All right.
Thank you very much.
Thanks, y'all. I had a blast.
Enjoy the sand, Dan.